Hello all. In this session, we will solve derivation to solve the problems. That is as same as the centroid. In the centroid, we have mainly derivations on all the geometrical areas, all the geometrical standard areas. That is triangle, circle, square, rectangle, semicircle, quarter-circle, like this, sector, like that. So in the same manner, in the moment of inertia also we have derivations. After deriving only we can move to the problems. Okay, so in this session I want to explain triangle, moment of inertia of triangle. Okay, moment of inertia, what will be the formula for the moment of inertia of a triangle? So here I have taken a simple equilateral triangle, that is height h and base b, height h and base b, and the base b is divided into 2, that is to the half, that is b by 2, b by 2. And here I have same as centroid. In centroid, if you watch centroid of triangle, I think the figure will be same. So here I have cutted a small elemental area. You can see this small elemental area. The thickness of that elemental area will be dy, and this height from the base it will be y, and the remaining if you minus this one, so it will be h minus y. So the small area, the length will be l, right? So this the thing. So that one, if the figure is perfect, then it is easy to derive the derivation. Okay, the moment of inertia of a triangle with respect to an axis passing through its centroid parallel to its base is given by the following expression, where B is the base width and specifically the triangle side parallel to the axis, and h is the triangle height, that is perpendicular to the axis to the and the base. And we can explain all these things, like for example, what I explained, that height is h, base is b, and it is half means it is b by 2, b by 2, and what is the distance of this, and what is the distance of this, and what is the thickness of this small elemental area, everything we have to explain. If they're asking for an 8 or a 10 marks, we have to explain all these things. Okay, here dix is equal to y square into dA, that is dA is equal to, what will happen, if you're shifting this side, it will be, the equation will be like this. And using similar triangles we have, so here you can see this small triangle, I'm taking one, and the whole triangle, two triangles are there, so we are taking as similar triangles. That is L by B is equal to h minus y divided by h. Then if you shift this side, keeping the L only, because L we don't know, right? See here, this L we don't know still measurement how much, so that's why we are separately finding the L. L is equal to B into h minus y divided by h. Therefore dA is equal to, if you substitute, 1 minute. Okay, if you substitute this L, see we got L value, if you substitute in this equation, that is dA is equal to B into h minus y divided by h into dy. Okay. Okay, so after that, so as I told, moment of inertia is a continuation of centroid. So the answer which we got here, the dA, so we need to do the integration now. Integration means increasing everything. Okay, integrating dix from y is equal to 0 to y is equal to h, it obtains, that is, it will be like, okay, integrating the portion now, that is y square into dA, we need to integrate this, and we need to give the limits for this. Here you can see, in while doing the centroid derivations also I have explained how to give the limits for the integration, that is 0 to, I mean minimum to maximum. Here you can see this is a 0 portion and the height is h, so the same the limits we are giving, that is 0 to h, so that is a limitation. So y square, if you integrate y square, so dA, I'm just substituting the dA value here which we got in the last answer, that is y square into b into h minus y divided by h into dy. So if you substitute this, b by h will be the common, so integration of 0 to h, that is hy square minus y cube, that is if you substitute, if you're integrating the y, so y cube into dy. So if you remove bh, b by h outside, so this will be h into y cube divided by 3 minus y to the power of 4 divided by 4. So the limits are 0 to h. So after substituting lower limit, upper limit, everything, so you will get bh cube by 12. You will get bh cube by 12. So after this, after doing the integration part, so we have to substitute in the main formula, that is parallel axis theorem. I think you have seen parallel axis theorem formula. So here once again you can see this is the permanent formula to solve the problem or formulas, that is ix is equal to ix bar plus ad square. If you substituting this ix bar, because here we are finding moment of inertia, right? So that's why it is going to shift this side. So ix bar is equal to ix minus ad square. So ix last we got bh cube by 12, right? So bh cube by 12 minus bh divided by 2 into h by 3 into whole square. So finally we are getting, if you substitute this, if you do all the LCM, so you will get bh cube by 36. That is the moment of inertia for a triangle. While doing the problems, always we have to take bh cube by 36. So please remember this. The formulas are very important to solve the problems. Thank you.